Greetings and friends to a session on commutation techniques in learning management system and e-learning program conducted by Department of Collegiate and Technical Education. Myself, Komla MH, lecturer from Government Polytechnic, Gurgaon. Today in my presentation, I am going to introduce you about commutation, conditions to be satisfied for successful commutation, working principle of line commutation. Here I will explain you its circuit diagram along with input and output waveforms. Next, a brief overview on forced commutation. Then, comparison between line commutation and forced commutation. We will classify the forced commutation. Finally, at the end of the session, let us have multiple choice questions based on above commutation techniques. You all are aware of turning on of SCR by various methods. Once the SCR is fired, that is turned on, the gate loses control over it, and please note down that even if we remove the gate bus also, SCR continues to be in conducting state, that is on state only. Therefore, we have to think of how to turn off the SCR. Turning on and turning off of SCR at proper time interval will help us in getting desired output voltage of all power electronic circuits. Otherwise, the efficiency of that particular circuit will be reduced. Therefore, it is important for us to understand the process of turning off SCR. So, this process of turning off of an SCR is defined as commutation. Now, let us see the conditions to be satisfied for successful commutation. And therefore, it is very important for us to remember the following points. The first point says that the anode to cathode current of the SCR must be brought below its holding current value. So, let us try to understand it by drawing the SCR diagram. So, this is a gate, this is a cathode, this is your anode. So anode will be always positive and cathode will be negatively connected in order to operate the SCR in the forward biased region. Since SCR is a unidirectional device, the current flowing through this anode to cathode is called as anode-cathode current. You also have studied about two different types of current levels, that is latching current, which is important in turning on an SCR, and holding current is important for turning off of an SCR. So therefore, anode to cathode current should be brought lesser than holding current value to turn off the SCR completely. In the second point, we will see the second condition where SCR can be turned off by reversing the voltage applied to it, that is by connecting anode to negative of the supply and cathode to positive of the supply. First condition tells you how SCR can be brought into off state by reducing the current, and second condition tells SCR can be turned off by applying reverse voltage. And third condition is related to dV by dt rating of SCR. So what do you mean by dV by dt? So dV by dt means how fast SCR anode voltage is varying with respect to time. For every SCR, the manufacturer specifies its dV by dt rating. If the anode to cathode voltage variations is more than the specified value, there are chances of SCR turning on again. Hence, its value should be always maintained lower than the specified value. Now we will see how this natural commutation process takes place. So here, this is the AC supply Vs. It is being connected to a SCR anode, and the negative of the SCR is connected to the resistor R, and the resistor another end is connected back to the AC supply. And this is the waveforms. This is the source voltage which is sinusoidally varying, from the period 0 to pi and negative cycle from pi to 2 pi. So now what we will do is at an angle of alpha, where alpha is the firing angle of SCR, once the SCR is turned on by giving a gate pulse during the positive half cycle, when the SCR will be in the forward biased state, so what happens is the current starts to flow in this direction. This is the direction of the current or the load current which will be flowing in this circuit. So that we can observe this in case of waveforms. So in these waveforms, this is the load current which is with respect to the omega t angular frequency. Now once the SCR is turned on, this load current will flow in this circuit. So this load current will flow from the period alpha to pi, because from after pi to 2 pi region, what will happen is the SCR will go to the negative cycle. So the negative cycle here negative and it becomes positive for the period pi to 2 pi. So once it becomes negative and positive, your SCR will be reversed bias and SCR will go into off state. So the current flowing through this SCR will be 0. So only this is what it is being shown in the waveform, where the current is naturally going to 0. So this is the voltage across the SCR. So the voltage across the SCR is appears across the SCR whenever the current will not flow in the SCR. So once the SCR current starts to flow, SCR will act like a switch. That is, switch will be in the closed state and very less losses will be there. So a very small voltage drop will be there. That's all. So only during the period 0 to alpha, where the SCR is not in a conducting state, the same voltage as of your source voltage will appear across your SCR. So during this, from pi to, that is alpha to pi region, SCR is going to be in the on state. So the voltage across the SCR will become 0. So the current will be maximum and the voltage will be 0 across the SCR. Again from pi to 2 pi region, the SCR voltage will be same as your supply voltage, because SCR is reversed bias in this region and SCR is not conducting. And from alpha to pi, SCR is forward bias and SCR is in the conducting state. So this type of commutation methods are used in the converters, AC voltage controllers, cycloconverters, etc. Now let us see what do you mean by forced commutation. So forced commutation is used when supply is connected across the SCR is DC or direct current. When the supply is AC or alternating current, which will be having a periodic positive and negative going cycles, which is sinusoidal in nature, alternatively the positive and negative cycles will be there. So during negative half cycle, the voltage across SCR will be naturally negative and SCR goes into off state. But in case of DC supply, where it is maintained or the voltage is constant with respect to time, so some external components have to be connected to commutate this device. So these external components are nothing but inductors and capacitors. So these inductors and capacitors, which will store the energy when it is connected in the circuit and current is flowing through it. That is when it is connected in the circuit along with the SCR, it stores the energy when SCR is in the on state, and this energy is utilized to reverse bias the SCR and bringing anode current below holding current and making SCR to go into off state. So this type of techniques are used in choppers and inverter circuits, where mainly the source of supply is DC in nature. Now we will classify forced commutation techniques or methods which has been used. The first is class A or load commutation. The voltage developed across the load is used to turn off the SCR. So hence the name load commutation. The second one is resonant pulse commutation or class B commutation. Here SCR is turned off by gradually build-up of resonant current in reverse direction. The third is class C or complementary commutation. So turning on of one SCR will forcibly make another SCR to go into off state and vice versa. Hence the name complementary commutation. The fourth one is impulse commutation. This is also called as class D type of commutation. So this impulse commutation method is also called as auxiliary commutation because auxiliary SCR will be used to apply a reverse voltage across the main SCR and turning on off of an main SCR. And the last one or the fifth one is your class E or external pulse commutation. Here, along with the inductor and capacitors, two extra SCRs are also being used to provide an external pulse to turn off the main SCR. So, these SCRs and the capacitors and inductors are going to provide the pulse externally to the main SCR. Hence, it is called as external pulse commutation. Now, we will compare the natural commutation and forced commutation. So as we have discussed in my previous presentation slides about the natural commutation and forced commutation, now we will going to tabulate it accordingly. So the first one says that there is no external commutation components are required in case of natural commutation because the supply is AC. Periodically or automatically current and the voltage will be going to positive, 0, negative, 0, positive. So the cycle is going on repeating. So no external commutation components are required to turn off the SCR. So SCR is turned off automatically for every half second. So in case of the forced commutation, since the DC supply has been given as an input, external commutation components have to be connected in order to make the SCR into off state. The second one, as I told you, AC supply will be an input to the SCR, and in case of forced commutation, DC supply or DC voltage will be input to the SCR. So this type of natural commutation techniques will be used in controlled rectifiers, AC voltage controllers and some other circuits related to AC where the supply will be AC. And coming to forced commutation, these type of commutation methods will be used in choppers where the supply will be DC, inverters, that is the name of itself will tell you it is going to convert DC to AC. So DC to AC means the supply will be always DC only. So obviously we have to go with the forced commutation method. So the fourth point tells you the power losses. So if you go with the natural commutation, no power losses will be taking place during commutation because we are not going to connect any extra components in the circuit. But if we go with the forced commutation, then obviously due to the connecting of an external components like inductors and capacitors, power loss will be taking place in these commutating components. The fifth one tells you SCR will be turned off due to negative supply voltage. But in case of forced commutation, SCR will be turned off by both voltage and current. So that is voltage and current both will play an important role in turning off of an SCR. So coming to the cost of this commutation, so the cost of the commutation of the circuit is nil. That is, cost is very less. But the forced commutation, the cost of the commutation circuit plays an important role because of the external commutating components which is being connected. The cost of the commutation circuit will rise accordingly. So according to this, if you again compare this natural commutation by all these points, we can see that this natural commutation process is very simple in nature. The circuit is very simple. But the same thing, a forced commutation circuit, the complexity is more. So the complexity of the forced commutation is much higher compared to natural commutation. These are some of the multiple choice questions. Now we will see some of the multiple choice questions based on the previous slides what I have explained to you. So the first question tells you natural commutation of SCR takes place when an anode current falls below latching current, anode current falls below holding current, gate current becomes zero, or voltage across the device becomes positive. To try to understand the question, natural commutation of SCR takes place. So try to think. The answer is anode current falls below holding current. So you have already known there are two types of current. Latching current, which is important when you are going to turn on the SCR, and holding current when SCR have to be turned off. So the commutation word itself will tell you it is related to turning off of an SCR. So anode current falls below holding current is the right answer. The third answer is the gate current. Even though gate current is removed, you know that the SCR will be in the on state only. So the fourth point will tell you voltage across the device becomes positive. So voltage across the device becomes positive means SCR is in the forward biased state. So that is SCR is in the conducting state once the SCR is turned on. So again the concept of turning off of an SCR will not consider in case of point 4. So the answer is anode current falls below holding current. Next, coming to the second question. The natural reversal of AC supply voltage commutates the SCR in case of first one resonant commutation, second is impulse commutation, third is line commutation, fourth is complementary commutation. So what is the answer? The natural reversal of the AC supply voltage. So the answer is there in the question itself. The answer is line commutation. So the natural reversal of AC supply will take place in line commutation because the resonant type of commutation where L and C components are used to produce a resonating current, that will come under forced commutation, and impulse commutation also it will come under forced commutation. Complementary commutation will also come under forced commutation. The line commutation is the one which will come under natural commutation. So the natural reversal of AC supply voltage for turning off of an SCR will be this line commutation. Next, the third question is parallel capacitor commutation is used in line commutation, load commutation, forced commutation, or external pulse commutation. What may be the answer? The answer is forced commutation because parallel capacitors are used in case of forcibly applying commutation techniques. So not in the line commutation or load commutation or external pulse commutation, but in case of a forced commutation method, parallel capacitors are being used. And the next one is, which type of commutation will increase the complexity of a circuit? So this question I have already answered in my previous slide when comparing natural commutation with forced commutation. So the options are natural commutation or forced commutation. If you recall the slide of comparison between these two types of commutations, then the answer is hidden there itself. So the answer is forced commutation, because in case of natural commutation, naturally the current on voltage will go to zero. So there is no need of any externally or forcibly doing the things. It will be done automatically for turning off of an SCR. But if we go with the forced commutation, where external components have to be provided for turning off of an SCR, so we need the forced commutation method. So only due to these L and C components present in the circuit, the complexity of the circuit is going to increase in case of forced commutation method. And cost wise also, natural commutation is simple and cost is less, and forced commutation, the complexity is more and the rate or the cost of the circuit is also more. Thank you.